feel free to ask questions still. Okay, so again, this unit is on stoichiometry. Stoichiometry has a very technical definition. If you are having to do this off of the video, pause it, write it down. Okay, I'm going to go kind of quick. All right, so it's a quantitative relationship between constituents in chemical reaction. Quantitative means numbers. So what it really means is it's how to calculate the amount of reactant needed or product expected in a chemical reaction. Farmers do this. Farmers take samples of their field and they measure the nutrients in their fields. And then they calculate how much they need to add for their plants and stuff like that. That's a form of stoichiometry. There is a lot of chemistry and biochemistry and stuff in farming today. If there was not, we could not feed everybody that has to be fed from our farmland. And we keep tearing up farmland to build more houses, which is fine until we run out. So, you know, they don't make more land really. I mean, volcanoes do, but it takes a long time before you can actually use it. Okay, so key point for this unit is the law of conservation of mass. Mass or matter cannot be created or destroyed in a chemical reaction. This is true of atoms, things like that. All right, some of you guys on your, especially on the predicting part, you added elements that weren't on the left, or you didn't account for elements on the right. That's not doable, okay? You have to have the same amount of things at the end as what you started with, all right? If you don't, you have to figure out where it went, okay? A lot of times people think, like, if you burn wood, well, it went away. No, it transformed into carbon dioxide and water vapor, which goes into our atmosphere. Or gasoline, you burn it, it puts out lots of vapors, all right? Sometimes we can see it. The people that have detuned their diesel trucks and roll coal and throw pollution everywhere, yeah, it's actually in most states it's a crime. Yeah. And it should be, they should be getting ticketed a whole lot more because it's horribly polluting. You're tearing up our environment. No, it looks like I'm an idiot. I'm sorry. I'm just going to go out there. It does not. It's like, I don't know. You're throwing dirt. It'd be like throwing dirt out everywhere. I don't get it. I like NASCAR, hearing engines like that at NASCAR going to races and stuff like that. That's cool. Hearing it go down my street at 11 o'clock at night, not cool. Not cool. So, all right. Yeah. Truck boys is right.
They be hanging out at Price Chopper.
Do they really? Okay. All right. These steps, guys, these are the steps for almost all of the problems we will be doing. Step one, convert whatever they give you to moles. Okay, we learned how to do that 2 units ago. We will go back over it today. You can do these in one problem or you can break them down. Some people like to do step by step. I'm okay with that. Some people like to do them in one problem. That's the way I do it. I will show you both ways. Yeah, I don't know why. Yeah, that's a good question. Can you guys see it well enough? It's kind of dark if I turn the little LED off. Can you guys see that?
I can see it.
Okay, we'll just go like that. All right. So convert it to moles. Now, I will tell you this. All right. Sometimes they will give you your reactants or the given amount already in moles, and that throws people off. Okay, I've had this happen. I always put 1 on the test like that to try and make an easier problem. And a few people, and a lot of times the people that really, really know it well, freak out. And they're like, but I got to convert it to moles. Well, it's already in moles, so what do? You go to the next step. You're going to multiply by the mole to mole ratio, okay? These are the coefficients from the balanced equation. We're going to talk about that today. That's a new way of discussing it. But this is the numbers when you are balancing equations that you put into the equation. Okay? All right. Then you're going to convert it to whatever units desired. Okay? Whatever units desired. Did they ask for grams? Did they ask for liters? Did they ask for molecules? Okay? We can convert moles to any of those 3. We can convert it even further if we want to, but I'm not going to get that complicated with you. All right? Okay. In the college class, sometimes we start with concentration, so you have to do a little extra step and stuff like that. That's okay. That's why the college class is the college class. We learn the basics here, we go on to the college class. All right? Whether you take it with me or you take it at your preferred university. All right? Now, all of these things, guys, are single step problems. Okay? I may even put this, because we're cramming, I may put these 3 steps at the top of the test. All right? Would that help you guys if I just have these 3 steps there? I might do that. I'm leaning that way, like the tower in Pisa. All right? Well, yeah, there's a good chance. All right, you guys ready? Moving on? I did. Yeah, it was sad. Yeah. You know, I'm not Catholic. I really, every time I heard of something, I really like what he stood for. Yeah. We didn't yesterday. We took it off because he died yesterday. Oh, my bad. All right. Huh? Yeah, let's think it was, maybe he planned it that way. I don't think it works that way. All right. Okay. But no, yeah, I really appreciated him as a human being and as leader and everything. All right. Okay. If we look at this equation, this is called the Haber process. It is how they can create ammonia in an industrial process using nitrogen and hydrogen. There's a whole process, pressure, and da-da-da-da. All right, the balanced equation is N2 plus 3H2 yields 2NH3. Now I left a blank there. If there is no number there, what number is there? 1. All right, so remember that. That's key. Okay? Always write down what is given. So we start out with given. All right? And then I use what do I want? Given and want. So in this problem it says if you have 57 moles of hydrogen, how many moles of ammonia can you produce? Okay? Now, this is one kind of like water. You need to memorize that ammonia is NH3. It just is. All right? There's no rule for it. That's just what it is. All right? Technically, it's nitrogen trihydride, but everybody in the chemistry, probably biology world, knows that it's ammonia. So it's just one of those things you got to learn. All right? So what did they give us? They gave us 57 mole H2. Okay? What do we want? Question mark, mole NH3. All right? Always start off that way. Guys, take that little bit of time. I saw where some of you guys tried to balance your equations on the test without writing all this stuff out. I told you guys, take your time and do it. And many of you that have missed 1 or 2 points, it's because you didn't do that and you didn't remember, oh, I got to go back and multiply this one by 2 to get it balanced. All right? Silly mistakes. Don't make silly mistakes. All right? Okay, so the first steps to convert what's given to us to moles. If we look at this one, they gave it to us in moles, right? The second step is multiply by the mole-to-mole ratio, which is the coefficient from the balanced equation. All right, so in our balanced equation, what this is telling me is that 3 moles of hydrogen is equivalent to 2 moles of NH3. So that is my mole-to-mole ratio. Can you guys see it okay? Oh, you can't see what I wrote? All right, let me slide it up. All right, so I wrote, given the 57 moles of hydrogen, what I want is the moles of NH3. Does that help? Yeah. Okay. All right. So what we always start with in our problem is what is given. In this case, 57 moles H2. Okay? You can put it over 1 or you can just cross this box out completely because we're not putting it over anything in this case. If you want it over 1, 57 over 1, same thing as 57, that is okay as well. All right? Oh, no. Oh, there it is. I thought I left my calculator at home. All right. Now, just like when we were doing conversions, this is why I like this method. This is why I teach conversions method. I have moles H2 here. Where does it need to go on the next step? On the bottom. All right? It becomes the same as before. How many moles is from the balanced equation? How many moles of H2 are in the balanced equation? 3. The coefficient. And then what I'm trying to find, in this case, moles of NH3. So how many moles of NH3? 2. All right? So 2 moles NH3 goes on top. All right? I can cancel out the unit mole H2. That leaves me just moles of H3. So I take 57 times 2, which would be 114 mole NH3 over 3, and plug that into my calculator because my brain's not wanting to do simple math this morning. There we go. And so that comes out to be 38 moles NH3. The one-step problem's not incredibly difficult, are they? You just gotta, what do I want? What am I trying to find? Are you with me? Everybody good so far? Any questions on where any of those numbers came from? All right, if we're all good, let's move on to the next problem. We're gonna make it, again, a little more difficult, which is fine. All right, no, we're not gonna do the apple pie one. All right, but you could do this. Guys, we could do this with an apple pie. I'm gonna kind of move on so that we don't take up time, right? If an apple pie takes 10 large apples, 2 crusts, 1 tablespoon, how many apples would you need to take 25 pies? Well, in this case, 1 pie is 10 apples, right? So it'd be 250. Yep, that one's a simple one because we know apples, right? Okay, now we're gonna keep the same equation, so we're not gonna redo equations and stuff like that, okay? We're gonna keep the same equation, but this time what is given is 463 grams of N2, all right? And what, now, it also tells me we have an abundance of hydrogen. What's abundance mean? Extra, very good. That means I don't have to worry about the hydrogen. A little bit later on, they might give you 2 starting parts, right? Like if I go back to my apple pie one, let's say I have 250 apples, right? But I have a half a cup of cinnamon. Anybody know how many tablespoons are in a half cup? 6. So 250 apples would make 10 pies, but the cinnamon's gonna limit how much I can make. Does that make sense? Because I only got 6 tablespoons, I can only make 6 pies. Unless I don't want to have my cinnamon in there, and you don't want a pie without cinnamon. It's, no, bad idea. All right, and then it goes, how many, what's this word? Molecules, okay, so what do I want? I want how many molecules of NH3? All right, are you with me? Bum, bum, bum. Okay. So we always start off with what they gave us. Oh, let's go back to our steps. What's the first step? You guys have it written down, right? Well, okay, yeah, write down, very good. All right, after that, when we get to the problems, then we have to convert the given to moles. All right, I'm gonna do this as 3 separate problems so we can see it, all right? And then I'm gonna show you how you can combine it into one. So we're gonna start with 463 grams of N2. If I have grams on top, where does it need to go on the next step? Bottom. Okay, now, how do I find the number of grams of N2? Where would I find that? No, not, that's how much we're starting with, but when we're doing our conversions, because we're converting it to 1 mole, right? So top and bottom have to be the same thing. Do you guys remember? And again, it's been a unit. How do we find the number of grams of N2 in 1 mole of N2? We're going to multiply it by what number am I pointing at? 2 times the mass off the periodic table, right? So for N2, remember, it's 14.0, so that's going to be 28 grams. It's the molar mass off the periodic table. Are you with me? Okay, so we go to the periodic table. Now, again, if it's more complex, right, then we would add all of them up. But N2's kind of a simple one to begin with. We'll do a more complex one in a minute. All right, So we take 463 times 1 is going to be, all right, and then we take 463 divided by, oh, you can't see the calculator, so I'll just get it out of the way. Divided by 28 is, all right, 16.5. All right. So if this was my final answer, I would just go 16.5. All right. But since I'm going to use it in another step, we don't want to round till the end. So we just go ahead and 16.54. We're going to keep one extra significant digit, and then grams would cancel, so that'll be moles of N2. All right? Now, what's the second step in our problem solving? Multiply by what? Multiply by the mole to mole ratio. Yeah, the numbers from the equation, mole to mole ratio. Okay? So we take this answer, and we're going to go, we start with it, 16.54 moles and 2. Okay? If I have moles on top, where's it go in the next step? Bottom. And this is moles of N2. How many moles of N2? 1. That makes it a little bit simpler. All right, and then what we're trying to find, which is NH3, goes on top, and it's going to be how many moles of NH3? 2. 2 moles NH3. So 16.54 times 2 is 33.08. And that's moles NH3. All right? Are you with me so far? Whew. All right. But what do we want for our final answer? Molecules of NH3. So I'm going to start my last step with moles NH3. I know it's silly, but the abbreviation for mole is just MOL. I don't know why. It's silly. All right, so if I have moles NH3 here, where's it go on the next step? Bottom. All right? And a key thing to remember, guys, everybody needs to remember this. On step 1 and on step 3, it will always be 1 mole here on this step. All right, so 1 mole on the top on step 1, 1 mole on the top on step 3. If we start with step 2, then it may or may not be 1. It's whatever it is from the balanced equation. But 1 and 3, it's always 1 mole. All right, you with me? Now, how many molecules are in a mole? It's a great big number. 6.02 times 10 to the 23rd. All right, that's Avogadro's number, right? And that's molecules of NH3. So we just take the 33.08 times 6.02 to the 23rd. And I get, let's see, how many, oh, we should have 3. So 1.99 times 10 to the 25th. And that's molecules, oh, sorry, if you're having trouble seeing it, let me scroll up. Molecules NH3. Okay, so step 1, oops, scroll it back down. Step 1 was converted to moles. Step 2 was the mole to mole ratio. Step 3 was to convert what we wanted, in this case, molecules. It could be grams. It could be, in some cases when it's a gas, liters. All right, are you with me? Now, I'm going to take this same problem. I'm going to show you how to do it in one long problem. Most of you, this is what you're going to end up doing because it makes it easy. For me, anyway, math-wise, it makes it easier, and you can make sure you set everything up in the first place. So it's still the same given, still same what I want. The first step is still the same. So we write can you guys see it? Yeah. 463 grams NH3. We're still going to convert it to moles. So 28 grams NH3 on the bottom, 1 mole, or not NH3, sorry, N2. I apologize. I was getting too fast in my head. So that's N2 and N2. I apologize. Can you guys forgive me? Thanks. Forgiveness is a good thing. Okay, now here's what we do. Instead of doing math at this point, because at this point I can cancel my grams, right? I've got moles N2. We can go straight to the second step, which is the mole to mole ratio. If I have moles N2 on the top, where's it go on the next step? Bottom, okay? And again, this moles is from the balance equation, so it's 1 mole. N2, we're trying to get moles NH3, so it's going to be 2 moles NH3 on the top. Now my moles of N2 cancel, only the unit, not the number. All right? And then we can go ahead and plug in the last step, right? So this part here goes here, moles NH3 on top, so moles NH3 goes on the bottom, and my 6.02 times 10 to the 23rd molecules, NH3 goes on top. Oh, I just ran onto another piece of paper, not bad. All right, molecules NH3, all right, goes on top. Now, why is this better? Well, I can take down and calculate everything on my calculator. So I'm going to go ahead, I'm going to turn the light back on for a second. Sorry. Okay. And I'm going to plug everything in. Now, what you do is you multiply everything on the top, then you multiply everything on the bottom. Well, the bottom's easy in this case. 28 times 1 is what? 28. So the bottom's going to be 28. So I multiply everything on top and divide by my answer on the bottom. All right, so 463 times 2 times 6.02 to the 23rd equals that number. Now I divide by 28, and I still get 1.99 times 10 to the 25th. One of the reasons I like this is there's less chances of writing something down wrong on a step. Because I see that, that's one of the reasons I have you show your work, okay? If you're doing this and you wrote 33.08 here, but let's say here you copied it over as 38.03, all right? This problem on a test would be worth at least 4 points, maybe 5 points, all right? If you just transpose numbers like that, I only take off 1 point. But if you do it all on your calculator at one time, you're probably not transposing numbers. Does that make sense? You see what I'm saying? So, yeah, what I see, and I've had kids on the college system, and unfortunately, the college thing, they enter it on online, so I collect their work, and I have to submit to the professor. I say, hey, I found this, and they normally will say, yeah, go ahead and give them some points back there. But what they'll do is, on their work, they write something down off the screen wrong or whatever, and most of the time it is, you just, you look at it, you go 33.08, and then you transpose or mix these two numbers up and you write it as 38.03. That doesn't mean you didn't know how to do it, you just made a clerical mistake, right? I hate to take off in chemistry for clerical mistakes. Does that make sense? But you're less likely to make a clerical mistake if you do it all in one problem. Make sense? So, same thing. Here's step 1. Remember, it's always 1 mole there. Here's step 2. That's going to be the ratio. Here's step 3. Just like we had step 1, 2, and 3. You can do it either way. Most of the time when I'm demonstrating, I'm going to do it this way unless you ask me, hey, will you show it in 3 steps? Yeah, I'll do that too. But this is the way, I mean, yeah, this is the way. Mandalorian, right? Okay. Sorry, it's not Star Wars, you didn't get it. But, okay. All right, let's do some more. What time is it? Oh, we got time. All right, let's look at, this is just some info. The balance equation, it's balanced in terms of molecules, atoms, moles, volumes for gases. Do you guys remember the molar volume if it's at standard conditions? Anybody remember? 22.4. All right, because all gases are the same, right? No matter what the gas is, right? Doesn't matter what their mass is, their volume's the same. If these are all gases, which they are, okay, it's also the liter ratio. So 1 liter to 3 liters gives me 2 liters because it combines in a different way. So you can actually skip some steps if you understand that. If you don't, just do the steps. All right? Okay, so I know I'm going fast. Another, this is the cookie one. All right, let's do another example here. Because like I said, tomorrow is going to be a work day. We're going to work on these kind of problems. I'm going to check you off as you get done. All right? Okay, so we have an equation here. Oh, I'm going to turn the light back off because it's too glary on the printout. Okay, it says 2 sodium iodide plus chlorine gas gives me 2 NaCl plus iodine. All right? How many grams of chlorine are needed to produce 10 grams of sodium chloride if I have excess sodium iodide? All right, so let's stop there. First of all, what's given? What's given in this problem?
10 grams of sodium chloride.
All right, which one's sodium chloride?
NaCl.
NaCl. So in this case, all right, just NaCl, sorry, started to put a number there. All right, it's just, in this case, we're trying to produce this much. So we need to, oh shoot, I need danger. All right. Hi, this is John. Okay, yep. Thank you. Bye-bye. Yeah. Okay. That way I don't say names on the video. All right. Okay. All right. So this time, and this is a common thing in industry. Hey, we need to make this much. Are we making 10 grams in industry a lot of times? No. But from how much you want to make, how much of the reactants do I need to have on hand? All right. So what do I want is, what does it say? Oh, grams of chlorine. All right. So I want to know how many grams of Cl2. Are you with me? Okay, now we go through our steps. The first step is to convert to what? Moles, okay? So we always start with what they gave us, 10.0 grams NaCl. Okay? If I have grams here, where's going the next step? Bottom. Now, we have to add it up because we have 2 elements. So Na, we have 1, Cl, we have 1, right? Na off our periodic table is 23.0. Chlorine is 35.5. So since it's 1, I don't even need to multiply it out. We'll just add it up. So 5, 8, 5. So it's 58.5 grams NaCl, and that's equal to how many moles? 1. Remember this step, it's always 1 mole. All right. It is important to label everything completely so that you make sure you cancel things completely, right? So I cancel my grams of NaCl. What's the next step? Look at your steps. What's the next one? The mole. What's it say? Step 2 is multiply by the mole-to-mole ratio. Yeah. Get used to use the right terms, okay? So if I have moles NaCl here, where's it go on the next step? Bottom. And then if I look at the balanced equation, how many moles NaCl? 2. Okay? Going forward, sometimes they'll be balanced for you. Sometimes they won't, and you'll have to balance it yourself. That's why that unit was important. All right, and then we need moles of chlorine. How many moles of chlorine goes on top? 1, because there's no number with it. All right, cancel my moles NaCl. Then the last step is to convert to what I want, and I wanted grams of Cl2. So if I have moles Cl2 here, where's it go on the next step? Bottom. 1 mole Cl2. All right, and then grams Cl2 goes on the top. Okay, I've already got my Cl, right? I already looked it up. So Cl, now I have 2 times 35.5 equals 71.0. So 71.0 grams goes up there. Mole Cl2 cancels. Right. You with me? All right. So now we can multiply our tops and bottoms. Because I'm going to have to divide, I like to multiply my bottom first. Okay. So light coming back on. So I'll take the 58.5 times 2, and I get 117. That's going to go on the bottom. Oh, I'll scroll up. 117 goes on the bottom. All right. Now, one more thing. One more reason this is such a good system. After I cancel my like units, what unit do I have left? what I want. This way, if I do this right, I know I've got it set up right before I even do the math. Does that make sense? That's another reason why I like this method. All right, then we're going to take 10 times 71, right? And that one I can do in my head, but I need it in my calculator anyway, so I went and multiplied there. And then we take 710 divided by 117 equals 6 point, let's see, we had 3 significant digits, so 6.07 grams Cl2. Okay, so that is my answer. You guys see how that works? All right, and again, step 1, step 2, step 3. You like it? Not too bad, is it? All right. All right, that's just some more practice problem. I'm going to go ahead and stop the video. And then if we need to do another practice problem, we can. Because it's already a 30-minute video.